Hi, everyone. In this video, we are going to look at three learning objectives. First, we are going to look at whether a given equation is a linear equation or not. And the second one is we are going to use addition principle to solve a one variable linear equation. And then finally, we are going to look at some application problems by setting up a one variable linear equation to solve. Okay, let's look at these learning objectives one by one. The first one is our first one. We want to determine whether a given equation is a linear equation or not. Being linear really means the degree of that monomial has to be exactly positive one, not even negative one, has to be exactly positive one. Regardless how many variables are in your equation. In other words, it's not about how many variables to determine whether it's linear or not, it's the exponent of that whole term. The exponent for that whole term has to be exactly one. Now, let's look at our first example. Determine whether the given equation is linear or not. So our equation A, we have 5x plus 9 equals 24. Now we only have a one variable term in this equation, and this variable term has a degree of 1. Remember, the degree of a term is the sum of all of the exponents of all of those variables in that term. So we only have one variable and the exponent is 1. So this is from definition, this is a linear equation. So the answer is yes, it is a linear equation. Now, our second example, we have 2x minus 9x squared equals 15x plus 7. Apparently, we have this exponent being 2. So this is not the definition of a linear equation. So the answer is no, it is not a linear equation. Okay. The reason, at least one of the reasons that we want to know whether a given equation is linear or not, because if you look at this first 4 letters in this word linear, is a line. So later on down the road, when we learn the graphs of linear equations, for a one variable or two variable linear equation, the graph will be a straight line. It will be a straight line, but that's for later. Now, this is your first set of exercise questions. You need to determine whether a given equation is linear or not. And the questions are on the second page. So this is your exercise question. Remember, for all of my YouTube videos, and the answer to these exercise questions are in the comments below the video. Now let's look at our second objectives. We want to solve a linear equation in one variable using the addition principle of equality. Now, first of all, let's understand the idea behind this principle of addition when we solve a linear equation. Actually, when we solve any equation. Now, an equation is pretty much like a balance. So a balance, if you have equal weight on both sides, it's going to be balanced, right? But it doesn't have to be weight. I mean, a balance measure weight, but in a broader sense, as long as both sides have same number, it will be equal, right? So this one is balanced, which means x plus 7 equals 9. Now, when we have a balanced balance, right? When they have equal weight, no matter what you do, and as long as you do the same thing on both sides of the balance, it will keep balanced. Let's try to understand this to see if this makes sense to you. So this is a balance. Suppose I have 10 grams of weight on each side. So it's balanced, right? How about I add 2 on both sides? If I add 2 on both sides, okay, this side is 12 grams, this side is 12 grams, still balanced, right? How about I subtract 2 on both sides? And this one become 10 grams, and this one also become 10 grams, as long as I do the same thing. Now still balanced, right? Even though numbers are different, but still balanced. How about I multiply by 2? This side become 20 grams, this side become 20 grams, and multiply by 2. How about we divide by 2? So this 10 divided by 2 is 5 grams, 10 divided by 2 is 5 grams. See, you can see we don't just have addition principle of equality when we solve equation. In general, whatever the operation we do, actually more than this, as long as we do the same thing on both sides of the equation, it will keep balanced. This is general principle. It's very important in solving equations. Okay, now let's look at our second example. We are going to use this addition principle to solve this equation. And since when we solve equation, no matter how complex, how simple an equation is, our goal is to have this unknown variable on one side by itself, so that you have x on one side by itself, the other side you have a number. We call it solution, right? Does it make sense? So in other words, the general direction when we solve an equation is get rid of everything from one side except that unknown variable. So in this case, we don't want negative a or minus a on the left-hand side. What we do is that we do the opposite operation to cancel it. Only opposite operation cancel each other. So this is minus 8, I'm going to plus 8. Remember, we do it on both sides. Okay, canceled. We get x equals, the other side is negative 15 plus 8, we're going to get negative 7, okay? But before I write negative 7, I want to go through another step for very good reason. So I'm just copy this negative 15 plus 8. And I like you to see something that is interesting and very useful down the road when you solve any equation. Say, if we don't look at this step, we just look at from the first step to what we have here. What happened from here to here? What happened? What happened is that it's equivalent to, when I add 8 on both sides, it's equivalent to that I move this negative 8 to the other side of the equation so that it becomes positive 8. Is equivalent. Imagine you don't do this step, you don't want to have a negative 8 on the left-hand side, just move it to the other side. As long as you change the sign to the opposite after you move it, then the equation is still equal. It's equivalent to you do something on both sides by itself. I mean, you do the same thing on both sides. So the equation will keep equal. You move a term to the other side of the equation, to the opposite side of the equation, left, right, right, left, opposite side, right? You need to change the sign to the opposite too to make sense. Okay, our answer is negative 7. Now, for the rest of examples, whenever we don't need a term, we just move it to the other side as long as we change the sign to the opposite. Let's move on to our next example. So this is our second example. So apparently we're solving for m. We don't want this 5. We move it to the other side. And 14, this is the plus, become minus. So we only have m left on the right-hand side. 14 minus 5, that's 9. So we solve it. M equals 9. M equals 9. And if you move this 5, let's look at the other way, another way. If you move the 5 to the other side, you can also put it on the in the front. Just make sure sign is opposite. If there's no sign in front of number, it means positive. So this way, negative 5 plus 14, you still get a positive 9. So it doesn't matter the order you put this number, you put in the front or put after 14, as long as your sign is correct, everything gonna be all right. Your second set of exercise questions. All right, now example 3, we are going to solve this equation and check the answer. For the previous 2 examples, we didn't check the answer because calculation is just one step. Calculation is straightforward, but we are going to do a check on this one. Just demonstrate how to check your answer when you have a solution to an equation. Notice that for this one, we have 2 variable terms, 5n and -4n. And they are on the they are on the same side. Whenever you have a variable terms or constant terms on the same side, this whole thing is an expression. Still remember what can we do to an expression? We can do 2 things to an expression. First, we can simplify it by combining like terms, or we can evaluate an expression for a given number for that variable. So now we can simplify this. We simplify an expression by combining like terms. Like terms are those that have exactly the same variable part. So 5n minus 4n, that's 1n. 1n, we just write it as n. We still have this -14. Then the other side, we can combine these 2 together, which is -5. We can always combine like terms, but as long as they're on the same side. Okay, now we don't need -14 on the left-hand side. Just move it to the other side. We have n equals -5 plus 14. So our answer is 9, positive 9. Now let's check our answer. We check our answer by, we learned this in the previous video actually, by replacing this n, this variable in the original equation by this answer to see if it makes the equation equal or not. So on the left hand side, we have 5 times n, which is 9, minus 14. On the other side, we want to check if they're equal or not. Oh, sorry about that, there's another term. Minus 4n, 4 times 9. On the other side, we have -12 plus 7. So this is a 45 minus 14 and minus 36. And the other side is -5. Let's say if they are equal. And 45 minus 14, that's 31. So 31 minus 36, is it equal to -5? And it is equal to -5. So they are equal. So the answer is, this is yes. This is the answer. We get a correct answer. Now this is your exercise number 3. Let me see if there's more exercise on the next page. So the first tool, we don't have more exercise for a third example. Now let's look at our next example. Solve and check, and no fundamental difference. The difference is that we have parentheses, and our goal remains the same. We want to have y on one side by itself. We do that by combining like terms and also after we combine like terms, we move those terms we don't want to the other side, so that on one side we only have that variable term by itself. So in order to combine like terms, we have to release this y from the parentheses. And that is why you need to multiply, you need to distribute the 3 to each term inside. As a principle, if you have parentheses, you always want to get rid of the parentheses so that you can combine like terms. So let's do that. 3y, and don't forget the other one, you have to multiply each term inside by the same 3. So 3 times -5, after you multiply by y, it becomes 3y. This y is gone. Only thing left inside the parentheses is -5. So 3 times -5 is -15. Then minus 2y equals -20 plus 2, that's -18. right? Combine like terms, 3y minus 2y, that's simply a y. Minus 15 equals negative 18. We don't want negative 15, move it to the other side. So we get y equals negative 18 plus 15. Remember, change the sign to the opposite. Now y equals negative 3. So pretty fast, actually. After some exercise, you can do it even faster, maybe. Now, let's plug this negative 3 back into the equation to see if both sides are equal or not. So we're going to check our answer. 3 times negative 3 minus 5 minus 2 times negative 3. The other side is negative 20 plus 2. This is negative 8. 3 times negative 8. And this is a negative times negative. Okay, or you can see minus 2 times negative 3, that's negative 6. The other side is negative 18. Now 3 times negative 18, negative 24, negative is plus, and equals negative 18. How about negative 24 plus 6, which is negative 18? So negative 18 equals negative 18. So it's checked. So this is our correct answer. This is our correct answer. Okay. Now your exercise set number 4. Now the last learning objective is that we are going to set up a linear equation in one variable to solve some application problems. So this is our example. And first of all, I'd like to say that when you solve application problems, even though we're at the beginning of this course, we call it pre-algebra. And almost every example is a simple one, but we need to learn a very important approach to solving application problems. Because when you go higher and higher in mathematics, it's not that easy anymore to just look at numbers, do calculation to get an answer. The most important part in solving application problems is to understand the information, the description, and then you represent the information in the equation in the correct way. That way, before even you do any calculations, you solve like 80% of the problem already before you even do any calculation. That's how important it is to understand the information, to represent the information correctly. Okay. Now let's look at this particular one. Laura wants to buy a car stereo that costs $275. She currently has $142. How much more does she need? Apparently, it's a super simple, and we can just solve it using common sense, right? But our goal is to learn how to solve equation by setting up equation, because this is super important. In real life, when things getting a little bit more complex, without equation, it's very hard to solve. Almost very hard to solve any real problems. So let's get started. So we know the total cost is this, and Laura only has 142. Apparently, she needs more. How much more? We don't know. That's why we need a variable in algebra to represent an unknown. So we know she has 42. We need to add some more dollar to 142 so that she has this amount, so that amount needed so that she can buy that stereo, right? So that's a common sense. Again, we set up the equation so that this equation actually makes sense. Now it's time to solve it. We don't want this 142 on the same side as x. We just simply move it to the other side. So x equals 275 minus 142. And this is going to be $133. So let me double check using calculator. I don't want to make silly calculation mistake. 275 minus 142. Yeah, 133. So she needs $133 more in order to buy this stereo. So we find the answer to this question. This is your last set of, let me have a peek. Yeah, this is the last one exercise for this video. And remember, all of the answers to the exercise questions are in the comment area below the video. See you in the next video.